You ever find yourself staring at a spreadsheet and the data just doesn't make any sense? The numbers are telling you one thing, but your gut is screaming that something else is going on. Well, a lot of the time, there's a hidden story, a hidden cause, lurking just beneath the surface. Today, we're going to pull back the curtain on a really powerful algorithm called AutoIV. It's designed to automatically find that hidden cause, even when the data is an absolute mess. So here's our game plan. First, we'll get a handle on this whole hidden confounder problem. Then we'll look at the classic way people try to solve it. After that, we'll dive into how AutoIV builds a way better solution, get into the nuts and bolts of how it works with a clever adversarial game, see if it actually holds up in the real world, and then we'll wrap it all up with the big picture.
All right, let's get right to it. The biggest headache in data analysis isn't just finding patterns. The real challenge is figuring out if those patterns actually mean what we think they do. It's that classic, age-old problem, separating a simple correlation from true cause and effect. To really see what I mean, think about this paradox. An airline is looking at its sales data, and they notice something weird. Every single time they raise their ticket prices, their sales also go up. The data seems crystal clear. Hey, if you want to sell more tickets, just jack up the prices. But that flies in the face of, all of basic economics. So what on earth is actually happening here?
Well, the answer is something called an unobserved confounder. It's basically a hidden variable that's secretly pulling the strings on both things you're trying to measure. So in our airline example, that confounder is something like holiday travel demand. See, when it's Thanksgiving or a huge conference is in town, demand goes through the roof. That high demand causes the airline to raise its prices, and it also causes a ton of people to buy tickets, even at those higher prices. The demand is the real cause, creating this totally fake, misleading link between price and sales. So how in the world do statisticians and data scientists deal with these tricky hidden factors? Well, for decades, the gold standard has been a pretty clever technique that uses something called an instrumental variable.
Okay, so what is an instrumental variable, or IV? The best way to think about it is like a clean external lever. It's something that gives your cause a little nudge, and this is the absolute key, the only way it can influence the effect is by going through that cause. It has no direct line to the outcome on its own. It lets you isolate the real relationship by cutting through all that noise from the confounder.
But here's the catch. You can't just pick any old variable to be your IV. It has to follow 3 super strict golden rules. First, relevance. It has to actually have some influence on the cause. For our airline, maybe something like regional fuel costs could work since that affects price. Second, exclusion. It can't directly impact sales. The price of jet fuel doesn't make people suddenly want to take a vacation. And third, unconfounded. It has to be totally separate from that hidden holiday demand.
And this, right here, is the massive problem. Trying to find a single variable in the messy real world that perfectly checks all 3 of those boxes, it's incredibly hard. As the authors of the paper we're looking at today put it, finding a valid IV is really an art rather than science, and it often comes down to an expert's intuition and, frankly, a little bit of luck. So, this is where things get really interesting. What if we could take that art and turn it into a science? What if, instead of hoping for luck, we could just get an algorithm to do all that hard work for us? Well, that is the exact promise of AutoIV. Now, the absolute genius of AutoIV is that it doesn't even try to find that one perfect IV needle in a giant haystack of data. No, instead, it takes the entire haystack, all of your messy, imperfect, real-world variables, and it intelligently builds a brand new perfect IV by pulling out and stitching together all the useful little bits of information. Here's the concept. You basically feed the algorithm a whole bunch of your observed variables. We'll just call the whole set V. AutoIV then acts like this incredible information refinery. It takes in that raw, messy V and separates it into 2 perfectly clean outputs. One is a valid instrumental variable, which it calls Z, and the other is all the junk, all the confounding information, which it calls C. Okay, so that sounds like magic, right? How does it actually pull off this incredible trick of separating information so cleanly? The secret is this really clever process that the creators call an adversarial information game. At the very heart of AutoIV, you've got 2 neural networks that are basically set up to fight each other. You can think of them as 2 specialists, and each one has been trained for a very specific and completely opposite task. They're in a constant state of competition. And here's how that competition works.
On one side, you've got the IV learner. Its entire job is to hunt for any piece of information that's related to the treatment, so our ticket price, but has absolutely nothing to do with the outcome, our sales. Then, on the other side, you have the confounder learner. Its goal is the polar opposite. Find all the information that is related to both the price and the sales.
A fantastic way to think about this is like a sound engineer in a recording studio. The full song, with all the instruments and vocals mixed together, that's your messy raw data. The confounder learner, well, it's trying to identify that whole mix. But the IV learner is like that expert engineer who's meticulously trying to isolate just the clean drum track, that underlying rhythm that drives the whole song, but isn't the melody itself.
And now for the final crucial step, the game itself. The whole algorithm is designed to make the difference between what these two learners find as big as possible. It literally forces their two outputs, the IV part and the confounder part, to share as little information as they possibly can. By pushing them apart like this, it guarantees that the IV signal gets scrubbed completely clean of any contamination from the confounder, and what you're left with is a pure, valid, ready-to-use instrument.
Okay, I know, that all sounds amazing in theory. It's a really cool, elegant idea. But the billion-dollar question is, does this clever game actually work when you unleash it on real data? Well, let's take a look at the results. These results from the paper really tell the whole story. On the left, you've got the raw data. It's just a noisy mess, a scatter plot where the true relationship, that hidden blue curve, is completely invisible. Now, look at the right. That red line is the relationship that AutoIV figured out using its newly built instrument. Just look at how closely it tracks that true blue line. It managed to cut right through all the noise and find the hidden signal. It's incredible. But here's the part that'll really blow your mind. In one of their tests, the researchers measured the prediction error, the mean squared error, where lower is always better. The error for the IV that AutoIV builds from scratch was just 0.19. What is absolutely wild is that this was even better than the error of 0.28 they got when they just gave the model the theoretically perfect, true IV to begin with. The instrument it built was better than the real thing. So let's zoom out for a second. What does this all really mean? What's the big picture here? Well, it points to a pretty fundamental shift in how we can tackle one of the absolute hardest problems in all of data science. The number one takeaway is this. AutoIV takes all the guesswork, the intuition, the art of finding instrumental variables, and it replaces it with a repeatable, data-driven science. And that is a huge deal. It means that real, powerful causal analysis, the kind of analysis that lets you find the true drivers of your business or your research, is suddenly way more accessible to way more people. You don't need decades of specialized statistical intuition to get it right anymore. And that really leaves us with a pretty fascinating final thought, doesn't it? This process took a piece of complex, almost mystical expert intuition and successfully turned it into an algorithm. It really makes you wonder, what other arts in data science are out there just waiting to be discovered and automated?